Hey guys, this is Mr. Ballant, just shooting out a quick video. There are two reasons why you've clicked on this video. Either one, you saw the video before we went back to school and had, I guess, nothing better to do with your time, and just felt like checking it out, in which case you've probably got a step up for everything that we're going to do in class the next couple of days. Or, and this is more likely, we've gone over some titration stuff in class, you're still really not sure how it works, and you're checking out this video kind of just to review what we've done in class, and I don't know, I guess just kind of try and go over it for the quiz. The idea here is that what we're going to do is called titration. I can only hope that that's how you pronounced it. Titration, good. Titration. Okay. This particular technique, it's not super clear. I don't know. I guess the word is that it can be kind of difficult to understand. And there are some classes that are going to try titration in a lab. So it's definitely one of the more difficult topics. So if it gets a little tough to follow, just pay close attention to what I'm doing and why I'm doing it. I am going to do the same thing that I normally do, where I'm going to run through that packet that we gave you guys for spring break, because there is a section for titration over there if you haven't seen it already. The idea is that, as the definition says, titration is the process of adding a known amount of solution of known concentration to determine the concentration of another solution. Essentially, if you forget kind of what concentration means, it kind of has to do with like when we did the Kool-Aid lab. More concentrated things or less concentrated things, we can use this process called titration to kind of figure out how concentrated something is. Let me show you, because we can do this mathematically. And there aren't a lot of formulas in this particular unit. It's mostly acids and bases. A lot of it's just vocabulary or writing neutralization reactions. But this particular topic, we do have a formula that we need to know, and it is important that we know kind of how to use it. Let me show you. So the first thing that we have to know is that as far as moles of H plus and moles of OH minus, if you remember correctly, the H plus indicates an acid, and the OH minus indicates a base. Now that should be kind of familiar from the titration video that I made. I hope you remember that one at least. But the idea is that as far as neutralization goes, the H plus ions should be able to neutralize the OH minus ions, and vice versa. The point being that 1 mole of H plus should neutralize or cancel out 1 mole of OH minus. And the way that you can tell that is by the charges. That was not an arrow. 1 mole of H plus should cancel out or neutralize 1 mole of OH minus. That's the basic principle behind titration and behind neutralization. The idea is that all of the acids should theoretically be able to cancel out all of the bases and turn to something neutral or balanced or even or zero charge. There is a formula here. The molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. And essentially what we're doing is we're checking the strength of the acid and the amount of acid we have against the strength of the base and the volume of the base that we have. Because what we're going to actually be doing is we're going to be mixing acids and bases together. And in order to figure out what kind of effect that has, like for example, if I take an acid and a base and I mix it together, do I get an acid or do I get a base or do I get something totally neutral? The way that we figure this out is by taking into account how strong our acid is and how much of it we have, and how strong our base is and how much of it we have. That's the principle. The formula behind it is Ma, which stands for molarity of the acid, Va, which stands for the volume of the acid, should equal Mb times Vb, again, for molarity of the base and volume of the base. That formula is given to you. So that is on the back of your reference tables. What is that? Table T. There is something that we do kind of have to take into consideration, though. So, like, we should also take into consideration the number of H plus ions that we have and the number of OH minus ions that we have. So the actual formula winds up kind of like this. So we have the number of H plus ions, and we're going to multiply that by our Ma, Va. And then we're going to have the number of OH minus ions multiplied by our Mb, Vb. And this is the formula that we're going to be using for titrations. That's like the short and sweet version of it. The idea is that we are looking at the number of hydrogen atoms that we have. We're going to multiply it by the strength or the concentration of the acid, and we're also going to take into account the amount of acid that we have. And then on the other side of the equation, we're going to take the number of hydroxide ions, or OH minus. We're going to multiply that by the strength of our base, or the molarity, and we're going to also take into consideration the amount of base that we have. If you think about it, if I have a very concentrated acid, that means a lot of H plus ions, right? And maybe I also have a lot of that acid. So all three of these things are maybe really, really, really high. On the other side of the equation, maybe I have very few hydroxide ions. And maybe the strength of my base is not very high because I don't have a lot of hydroxide ions. And maybe I don't even have a lot of base. Maybe I only have a little bit. We would then be able to ideally understand how strong the product is. Obviously, we're going to wind up with something more acidic because all of my acid concentrations and volumes are high, while all my base concentrations and volumes are low. That's kind of the short kind of explanation here. But this is kind of the formula that we're going to be looking at. So let me just kind of get rid of all that for a second. The easiest way for me to show you how to use this formula is just to jump right into the practice, and that's why we have some practice problems right over here. Okay. So we got, what is the concentration of hydrochloric acid solution if 50 milliliters of a 0.25 molar potassium hydroxide are needed to neutralize 20 milliliters of the HCl solution of unknown concentration? So right away, there's a lot of stuff in this problem. This is kind of one of those things, if you remember correctly, the gas laws equations, when we did PV equals nRT, there were a lot of numbers in those kind of questions too. So the most important skill here is identifying what numbers you have and plugging them into the correct spots on the formula. So let me show you what I mean. Let's kind of make this a little bit bigger just so that we have a little more space to work with. Or not, because I'm cutting off the question. There we go. Okay, that's good. Okay, so the first thing that I want to do is I want to identify which things are part of the acid and which things are part of the base. I should know just by the name hydrochloric acid, that's HCl. So that's right here actually. So that's my HCl. That's the hydrochloric acid, so I'm going to use red for the acids, just like I do normally. And it says, let's see, KOH, so that OH right there, that tells me that's the base. Let me make that a little. There we go, a little base. That's potassium hydroxide. That should also be on your reference tables if you don't know the name. Let me also underline this because I can see that that is molarity, that big M right there. That's molarity. That's the strength, 0.25 molar KOH. So that's going to be the strength of the base. So that's also important to kind of note. And it also says 50 milliliters. Ooh. I'm like trying not to cross out. Sorry, this pen's very hard to use. There we go. 50 milliliters of a 0.250 molar KOH. So that right there, those all those things are kind of the base units, like the ones for the bases. It's the volume for the base and the molarity for the base. So we also have down here 20 milliliters of the acid, HCl, right? And I don't know the concentration. And that right there, by the way, is the question. What is the concentration? So all I have to do here is plug in my formula. So I'm just going to write really quick number of hydrogen times Ma times Va equals number of OH times Mb times Vb. Now this is a great starting example problem because it actually simplifies it down a little bit. For example, how many H pluses are in this thing? There's only one, right? So I could plug 1 in for my number of hydrogen atoms, right? I also, because it's just a 1, I really don't have to write it. I could just get rid of it. And the same goes for my OH. Do you see that? There's only one OH in that thing. So I could also plug in a 1 for this. So in this particular problem, the number of H's and number of OH's don't actually matter too much. So I'm actually just going to simplify this, and I'm just going to get rid of them. Because there's just one each. It's almost kind of like they're not there. So it actually simplifies this problem a lot. It is important to keep that in mind, though, because there might be problems in the future which do change the number of H's and OH's, but we'll get to that another time. Essentially, it's just MaVa equals MbVb. Now, all I have to do is plug in those numbers. I don't have the molarity for the acid, because that's what they want us to find. So I'm just going to make that my X value. I do, however, have the volume of the acid. That's right here. 20 milliliters. On the other side of the equation, I do have a molarity for the base, and I also have a volume. So I'm just going to plug those right in. That looks like the volume is 50 milliliters, and the molarity is 0.25 molar. So now all I have to do is multiply those out. What do we get here? We should get, sorry, I'm just kind of doing it on my calculator really quick. That looks like X equals 0.625 molar HCl. That's the molarity of my hydrochloric acid right there. And I mean, I'm assuming that everyone can follow that algebra, but all you got to do is multiply these two together, and then you just divide by this guy right here. So not too difficult, I guess. So that's the easiest kind of problem that you can see. Don't be intimidated by the way that it's phrased. All you have to do is like circle or underline the most important parts of the equation and just plug them into the formula. Let's kind of keep going here. Let's throw this up there. All right. Okay, get rid of that. So I'm going to run through this a little quicker just because, again, I know my last video was a little long, so I kind of want to keep this a little shorter if I can. What is the concentration of sulfuric acid of the solution? All right, so ready? I'm going to go ahead. Sulfuric acid is my acid. Again, it's asking for the concentration. I can see that this 50 milliliters, 0.25 molar, KOH, that's all my base stuff. 20 milliliters of the sulfuric solution of unknown concentration, that's my acid stuff. What we do have to do here is we're going to have to check the sulfuric acid here. because if we were to look, we have to look up the actual formula for sulfuric acid. So sulfuric acid should be, if I look at the reference table, H2SO4. That's sulfuric acid. And it says here we've got KOH. So this is kind of what we were talking about, where it kind of depends. You have to be careful because in here, obviously, we have 2 hydrogens instead of 1. And that's definitely going to affect our result here, because the idea is that if I have some sulfuric acid, not only do I have just 1 hydrogen atom, that'll cancel out this 1 hydroxide atom, but I have a second one. And that second one is going to, it's going to, like, sulfuric acid will have more hydrogen in it than potassium hydroxide will have hydroxide. The point is that we have to be really, really careful because there are now 2 hydrogens. So what we're going to do now is when I plug in my number of hydrogen atoms, which now is 2, and I'm going to plug in, I have my volume, which is 20 milliliters. I don't have my concentration, so that's going to be my X. I'm going to plug in the 1 for my hydroxide because, again, it's just 1 hydroxide for this thing here. That was like... Okay. 50 milliliters of base, 0.25 molar concentration. And then again, all we have to do is kind of solve. If you solve this one out, I believe X should equal 0.313 molar of H2SO4. Now, if you don't include that 2 hydrogen atoms, obviously it's going to throw your your calculations off a little bit. So you have to make sure that you remember that. That's why I'm trying to get us into the habit of writing down that number of hydrogen part, that's right here, and the number of hydroxide part, which is over here. Because sometimes you get something that can affect that. Anyway, let's just go ahead, let's just keep going. Okay, how many milliliters of 2 molar H2SO4 are required to neutralize that many milliliters of that much molar sodium hydroxide? So again, I'm just going to label my... So again, it says how many milliliters. So like I need to know, that's a volume, I need to know that, but this time they give us the molarity. This is also important to know because again, I see that little 2 that's right there. That's gonna be important. And over here we've got 30 milliliters of base, 1 molar NaOH. Okay, I only see 1 OH here, so that's good. I don't have to worry about that. Now all I'm gonna do is I'm gonna write that in. I still have 2 hydrogen atoms in my H2SO4, so you see I have 2 hydrogen atoms in there. This time I have 2 molar, and I don't have my volume, so that's going to be my X. And that's going to equal to 1. So that's the 1 hydroxide that I have right there. 30 milliliters and 1 molar. Cool. That should wind up being, let's see if I just do that really quick. So what is that? 30 divided by 4, that's 7.5 milliliters is what I'm getting. So again, that's just 1 times 30 times 1, which is just 30, and then divided by 2 times 2, which is 4. So just algebra that out, I guess. But yeah, I hope you're following along so far. This is technically the last practice problem that I have here, that we have on the packet. So I'm going to go through this one, and then hopefully what we have in class will also help you out a little bit. But anyway, let's just run through this while we're on a roll here. It says how many milliliters of 0.10 molar calcium hydroxide are required to neutralize 25 milliliters of 0.5 molar HNO3. Again, there's a lot of stuff in here. I'm just going to start by labeling everything. I can see that this has OH in it. That's going to be our base. That looks like my molarity, and it's saying how many milliliters, so that's the volume that I need to find. If I go all the way over here, HNO3, that would make that our acid because there's an H at the front there. That's my molarity, that's my volume. All I gotta do is now plug them into the formula. I'm just going to make it easy on myself. I'm going to put the base stuff over here. I'm going to put the acid stuff over here. The number of bases that I have, this time we got to be careful because do you see that little 2 right there? There's not one hydroxide, there's 2 hydroxides. So I'm going to put 2. I don't know my volume, but I do know my molarity. So my volume is X. I have 1 hydrogen atom in that acid over there. I'm going to multiply that by 25 milliliters, and I'm also going to multiply that by, oh Jesus Christ, I'm running out of space, 0.5 molar. So let's see if I math that one out really quick. That one should be, let's see, the volume should equal 62.5 milliliters of calcium hydroxide. So you see, it's like the idea behind titration is definitely a little difficult, and we're going to get some more practice with it. But for now, all I want you to be able to do is to look at some of these more simplistic titration problems and be able to calculate them out a little bit. And the most important part is just taking into account for when they change the hydroxide ions or the hydrogen atoms. So you just got to be really, really careful about like whether they stick a 2 here, or whether there's just 1 hydrogen atom there. You just got to make sure that that's reflected both here and here. But yeah, so that's the short and quick version. Hopefully this helped a little bit. Hopefully it helped you guys with some practice. Or if you're looking at it before class, hopefully this gives you a leg up and it makes class a little bit easier the next couple of days. And yeah, I'll see you guys in class.